Okay, so for this one, I'm doing number 1. And we can already see that there's 51 minutes, 35 seconds. And the frequency is 622.25 hertz. And the speed of sound is 343 meters per second. So the first question asks, if the note he sustained was an E flat at 622.25 hertz, what was the wavelength of the sound? Assume a speed of sound of the air in the air of 343 meters per second. So let's put that down, 343 meters per second. And we have to use the formula for wavelength. So we divide that into the frequency, which was 622.25 hertz. And let's see what we get. .55. And this is now the wavelength of the sound. So which is wavelength. So I usually like to write out my things like this, that way I can come back and not be confused, because I get confused pretty easily. So we've already got one part of the problem done. So now we move on to the next. So we go back to the total time, which is 51 minutes and 35 seconds. And the question asks, given the frequency, how many waves were there in 51 minutes and 35 seconds? So there are 60 seconds in 1 minute. So let's multiply 51 times 60. So now we get 30, 60 seconds, seconds. All right, so now we gotta bring in the 35. So, I mean, this is, they're both seconds, so we just add in the 35, which will come out to be, I'm sorry, let's write this out. 30, 60 plus 35. Okay, which comes out to be 95 seconds. Okay, we're gonna come back to this. So now we know that the frequency, we already know that the frequency is 622.25 hertz. Now we have to use that number. So let's divide that. Let's divide 1 into 622.25. And we get 0.016. Okay, so we're almost done. Last but not least, we have to get the number of waves, because, you know, we gotta get the waves, which is in 51 minutes and 35 seconds. So we gotta divide the total time, which is 30.95. So divide 30.95 into 0.016. Let's see what this comes out to be. All right, so the big number is 1,934,375. Therefore, there are 1,935,375 waves in 51 minutes and 35 seconds.